Welcome. In this session, we'll continue with the discussion of Z transform, and in our goal in this session is to compute x of n if x of z is given to us. So, how to compute x of n from x of z, and this is termed as the inverse Z transform, and we know the formula for this is given as x of n can be computed from x of z by using this formula, and this formula is termed as the inverse Z transform formula. And remember, this one follows the complex integration. So this is the complex integration, and actually we never resort to this formula in this formula because it is the contour integration and it's a very tedious task. And so what we do, we use a direct mapping between x of n and x of z. In other words, if we say x of the Z transform of x of n is x of z, then inverse Z transform of x of z is x of n. What do we mean by this? This will be clear in a minute. Now, two important formulas that are very important for this are the Z transform of a raised power n u of n is 1 by 1 minus a z inverse when magnitude of z is greater than magnitude of a. Same way Z transform of e raised power minus n u of minus n is this. And then magnitude of this is less than. What do you mean by direct mapping? Direct mapping means if Z transform of this is this, then inverse Z transform of this is simply this. That's the meaning of direct mapping between this x of n and x of z. That's the meaning of direct mapping between x of n and x of z. And these we will convert. What we will do, we will convert x of z, every x of z in these two formats, and we'll see if the region of convergence is this, then inverse Z transform will be this. If region of convergence is this, then inverse Z transform is this. So we'll want to convert every Z transform in these formats. Now there are several ways to convert means to obtain x of n from x of z. For example, long division method, partial fraction method, and so on. Now in this session we will resort only to the partial fraction method, means we will learn how to obtain x of n using the partial fraction method. So in this session, we learn the partial fraction method of this inverse rate. And there are several methods that we can resort to, and I will illustrate this by using an example. Let's suppose x of z is given to us, and x of z is 1 by 1 minus 1.5 z inverse plus 0.5 z. So this is the Z transform of any sequence. What will be x of n? What will be x of n using this partial fraction method? Now the first step in this partial fraction is what we do. We multiply the numerator and denominator by the, sorry, this is 2, this is minus 2, by the highest power of this z. So we multiply the numerator by this z square and denominator by z square. Let's see what's this equal. This will be simply z square by z square minus 1.5 z plus 0.5. Sorry, not z square and z square will cancel, so let's not part of this. Then what we do in the second step, what we do, we divide the both sides by z. We write it xz by z, and if I divide on the right hand side, only z will remain. Then we, in the third step, what we do, we factorize this, and we factorize this in such a way such that the factors look like this. Factors should look like this. That should be the goal. Now this will be clear in a minute. Let me proceed to the next step. This will be clear in a few seconds. So if we factorize this, and if you take the factor of this denominator, it will be 0 minus 1. check it. This is clear. You can do the factors, calculate it, compute the factors. Then what is meant by partial fraction method? This is partial fraction method actually. We write z by z minus 1 and z minus 0.5. Whatever is on the right hand side, we write it like a by z minus 1. You might have already seen it, Laplace transform. So this is b divided by z minus 0.5. Then we multiply on both sides by this denominator term. What we'll get z, and if we multiply on this side by this, we are left with only z. On the right hand side, we'll get a into 0.5, b into 0 minus z minus 1. So this is what we achieved after multiplying on both sides by this. So to multiply this first z minus 1 and z minus 1 will cancel, we will be left with only this. Same way, if we multiply this with this term, z minus 0.5 will cancel with this one, we will be left with z minus 1. Now to obtain the value of this a and b, what we do, we first set, we make the z to go, z term, this b term to go equal to 0. So we make this b term to go equal to 0. So to make z b term to go equal to 0, we say z equal to 1. Z equal to 1, then this whole term is gone. We'll be left with z is equal to 1 into 1 minus 0.5. If you subtract half from 1, we are left with half. So you can say a is simply 2. So you can get the value of a equal to simply 2. Same way to compute the value of b, we make this equal to go to equal to 0. In other words, we set z equal to 0.5 in this. So we are left with 0.5. This term is gone. So we will be left minus 0.5 minus 1 is minus 0. Again half, but minus. So we can get b equal to minus 1 from this. So going back to this, we obtain a is 2 by z minus 1 and b is minus 1 and z minus 0.5, and we see this is equal to x z by z. This whole term is equal to x z by z. So we can say this is x z by z. Now I can write this quantity. Let me write at the bottom. I can write it as x z by z is equal to 2 by z minus 1. Sorry, 2 by z minus 1 by z minus 0.5. Now multiplying both sides with z, this will be twice z minus 1 minus 1 by z minus, sorry, there will be z also. So multiply both sides by z. Now dividing the numerator and denominator by z, this will have z minus z inverse minus 1 by z, sorry, z is gone. We will have to get 1 minus 0.5 z. So this is our x of z. So we have factored x of z using the partial fraction method, and we arrived at this. So this is our z transform. Now you can see it is in this form. It is in this form 1 by 1 minus a z. So you can check each term is in this form. Here a is equal to 1. Here a is equal to 0.5. Now whatever is the region of convergence, means ROC mentioned accordingly, you can convert this to, if ROC is, if I say ROC here is Z is greater than magnitude of A, then you know this should be the Z transformer. Means you know this is the Z transformer. A raised power m mu of n. But if ROC of this is given as z is less than a, then you know this will be equal to this is the z transform of minus a raised power n u of minus n minus 1. So this will be equal to, so means in the z transform this is equal to this. If this is the ROC, and z transform of this is equal to this if this is the ROC. So based on the ROC, we can convert it into appropriately either to this or to this. Follow. So let's take the example. If the ROC was given like this, if the ROC is given like this, if ROC is greater than 1. Means the region of convergence is outside the unit circle. Now you can see the inverse Z transform of this outside the unit circle means A is equal to 1. Now here A is equal to 0.5, here A is equal to 1. You can write x of m from this. You can say this is 2 into 1 raised power m, so you can resort to this formula because it's saying it is outside that circle, and here A is equal to 1. You can say this is 1 u of m minus 0.5 raised power n u of m. Now, why I converted this into this form means why I converted each term into this form. Why not to minus a raised to n minus n minus n? Why not to this form? Why not to this? Why I converted into to this form? You can say I said earlier the region of convergence when we have sum of two or more terms, the region of convergence is the common region. Now you can see the region of convergence is greater than 1. So region of convergence for this case, this should have region of convergence greater than circle. The region of convergence of this is greater than 0.5 based on this. So 0.5, but outside this 0.5. And region of convergence, we know when we have sum of two or more Z transformers, the region of convergence is the common region. And you know Z is greater than 1 satisfies that. So that's why I converted both the forms in this a raised power n u of n. Practice it, you will get the idea. Now, second, suppose the region of convergence is, second case, if I say region of convergence was, let me take the second example. Let's suppose ROC was given here like this. Suppose the ROC is less than 0.5. So ROC is inside 0.5. So the region of convergence of the whole Z transform is region of convergence of this is I think it was 2 minus 1 by 0.1. Now, region of convergence is less than 0.5, so it's satisfying that definition. Z transform of this is this equal to 1 by 1 minus a z inverse when z is less than a. You can check it when z is less than a. Now here a is 1, here a is 0.5. You can say so the region of convergence of this will be less than 1 and region of convergence of this will be less than 0.5. But I said the region of convergence is the common region. So region of convergence of this is less than 0.5 and region of convergence of this is less than 1. So which portion is common? Less than 0.5 is the common. So you can say this satisfies actually this one. So we can say x of n from this we can write it as 2 minus 1 raised power n u of minus n minus 1. Then this will be minus times 0.5 raised power n u of minus n minus 1. Now this can be 1 raised power n is 1, and if I take u of minus n minus n common, this will be 0.5 raised power n u of minus n minus 1. So this is the x of n when region of convergence is inside this point from circle. Alright, now x of z is given to us. What's x of z? 2 by 1 minus z inverse minus 1 by 1 minus 0.5 z. So this is the Z transform. Now if I say the region of convergence is 0.5 less than magnitude of z, sorry, less than magnitude of z, less than 1. What is the saying? Means the region of convergence is greater than 0.5 but less than 1. In other words, the region of convergence is, you can say the region of convergence now is greater than 0.5 but less than 1. So the region of convergence is greater than 0.5 but less than 1. So in other words, the region of convergence is the range. So it is greater than 0.5, 0.5, and it is less than 1. It's less than 1. It's greater than 0.5 but less than 1. So in other words, it is the same. Now, which one satisfies less than 1 among this? Here is for n u of minus n minus 1. as Z transform as 1 by 1 minus A Z inverse, and magnitude of Z is less than A magnitude of A. You can see this one actually satisfies this when Z is less than this. So this second part is satisfied by this. And this, the other part means it is greater than, we know the Z transform of U of minus C is simply 1 by 1 minus A Z inverse when Z is greater than magnitude of A. And A this time is 0.5, and that is satisfied by this one. So you can write the inverse Z transform of this directly. You can say this will be 2, and since this one satisfies less than 1 satisfies this definition, you can substitute the value. This is minus 1 raised to n u of minus n minus 1. And the second part satisfies this definition. So you can say this is 0.5 raised to n u of n. So if substitute the values, and this is twice 1 raised to n is 1 minus 0.5 raised to n. So this is the inverse Z transform if the region of convergence is. So this is the inverse Z transform. So this is how we calculate the inverse Z transform or x of m from x of z. I hope you understood. Please practice it. You will get the idea. In the next session, we'll see how to solve a differential equation using Z transform.